So this is 2008 Form B of the AP Calc AB exam. Situation is described, it's a non-calculator question, and the situation that's described is that g is a continuous function, we know g of 2 is 5, and then we're given the graph of g prime, so we're given the graph of the derivative of g. What they ask us to do in part A is to figure out the x-coordinates of all the points of inflection on the graph of g. So we know that concavity and inflection points are determined by the second derivative. When the second derivative is positive, our graph's concave up, and when the second derivative is negative, our graph is concave down. So what we typically try to do is we typically would try to build a sign chart for the second derivative in this case. We can only really fill in this sign chart for the interval of the number line from -3 up to 7. And if this is a sign chart for g double prime that we're trying to build, we would need to have points between -3 and 7 where g double prime is 0 and where g double prime is undefined. This is a graph of g prime. Now the derivative of what's graphed here would be g double prime. So if we want to know values of g double prime, we're going to look at slopes of the tangent lines. So the tangent line has a positive slope that's the same value on this piece of the graph. And then we have a cusp right here. So g double prime is actually undefined at that cusp. Right? The first derivative is not differentiable at the x value of -1, and the derivative of the first derivative would be the second derivative. So g double prime is undefined at -1. It's undefined at this cusp, and it's undefined at this cusp. There are no places on this graph where the slope of the tangent line is 0. The three x values where we have cusps are -1, 1, and the x value of 4. So what is the sign of g double prime? What is the sign of the slope of the tangent line on this interval? Well, we have positive slopes between -3 and -1, so that's g double prime is positive. In between -1 and 1, we still have positive slope. So -1 had to be a candidate for an inflection point, but we don't actually have a sign change for the second derivative there. Between 1 and 4, we're looking at negative slopes for the graph on that interval. And then from 4 to 7, we're back to positively sloped tangent lines. So this would mean that g is concave up between between -3 and -1, still concave up between -1 and 1. Then we change to concave down between 1 and 4, and then we're back to concave up from 4 to 7. So what are the x-coordinates where we have inflection points? Well, we have inflection points at the x values where we have changes in concavity. That happens at the x value of 1. We have a change from positive concavity to negative concavity, concave up to concave down at 1, and we have another change in concavity at 4. Now I'm not going to really write out the justification, but the justification would be what I just mentioned. The graph changes from concave up to concave down as we cross the x value of 1, and concave down to concave up as we cross the x value of 4.